In section 4.1.14, we want to match the linear correlation coefficient to the scatter diagram, where r is equal to negative 0.546. Now let's go over the definition. The linear correlation coefficient r is a measure of the strength of the correlation and also provides information about whether the correlation is negative or positive. The linear correlation coefficient is always in between the values of negative 1 and 1 inclusive. Because this value is a decimal, that means it's in between negative 1 and 1. Now, if the correlation coefficient is positive, then the correlation is positive. If the correlation coefficient is negative, then the correlation is negative. Now, if the correlation coefficient is negative, as it is less than 0. Now, the closer r is to positive 1 or negative 1, the stronger the evidence of association between the two variables. It is very close to negative 1. If r is equal to positive 1, then a perfect positive linear relation exists between the two variables. If r is equal to negative 1, then a perfect negative linear relation exists between the two variables. The closer r is to positive 1, the stronger is the evidence of positive association between the two variables. The closer r is to negative 1, then the stronger is the evidence of negative association between the two variables. And if r is close to 0, then little or no evidence exists of a linear relation between the two variables. Now, we want to choose the correct graph according to what this linear correlation coefficient is, which is negative 0.546. If we look at this graph, the first one for part A, you can see that this develops a straight line between that. So that could be a really positive, strong linear correlation because it creates a line. There aren't too many that's scattered away from that. Now, if we look at B, here we have a line. We can put a line through that data. And if we put line through that data, again, we don't have too many that's scattered outside of that or many outliers, but it's going down. So it's a negative linear relation, and it's a perfect, almost a perfect negative linear relation because all the points are still close together. Now, if we look at C, okay, now we can draw a line through this data, okay, but they're not as close together as it was in B. So it's not as strong. And the reason why it's not as strong is because, again, the points are a little bit further away from each other. But it is going down, and it is negative. So that's going to resemble close to what r is equal to, which is negative 0.546. If we look at D, okay, these points are really, really close together, and it's creating probably the strongest out of them all because that's creating a line there. So the answer is going to be C.